Thank you, Claire. So welcome everybody for our built environment core panel. So we'll start with a very brief presentation actually. Um, and I'm not gonna repeat many of the things that we have done, so we will have a little bit more time for discussion from the audience with our panelists. So you know that as you saw from the other course, Anna and Claire made a great job putting like a summary of the main findings from each core, and I think you're gonna have that available. So I'm gonna go over just a few of those to go straight to the questions. So I think the first thing we wanted to underscore from our core is that we have really heterogeneous typologies, both from the street design, but also from the landscape variables that we have developed in the built environment core. And that's one thing we want to underscore. Regarding mortality and life expectancy, just to underscore something that I haven't seen in the other presentation is that density is a really important thing, and it really covered, it has a very important aspect right now with our pandemic. But what we have found is that dense cities have higher proportion of communicable mortality and also violent injuries, deaths. And we know that we are a region with one of the highest violent injury deaths prevalence. The other thing that I wanted to underscore here is that fragmented cities and cities with higher street connectivity had lower proportion of these communicable deaths and also unintentional injuries and violent injuries. And lastly, it was a really nice paper on showing that city healthcare amenable mortality is associated with higher fragmentation. So some of the findings that we had from the papers that are either under review or have been reviewed in the PMP committee. The other thing that we have found is that, and I think that was common in the other course, is that higher density and fragmentation is associated with higher prevalence of hypertension. And regarding air pollution, which is going to be our next webinar, I just wanted to underscore that when we go into level 2, subcities with higher intersection density have higher PM2.5, and subcities with more greenness have lower PM2.5. And those are some of the innovative findings that we didn't really have for our region. And as I said, you will have the summary of the main findings of health outcomes and also built environment indicators that we have from several proposals and papers. The other thing I wanted to underscore here is since our last meeting, we have, first of all, the documentation, as Anna said, of all the built environment variables that we have developed for different scales for level 1AD, level UX, level 2, and now we're thinking what's going to happen with level 3, which is a large discussion that we'll have with different cores. But we also have 10 more variables since our last meeting that probably some of you are not aware, and I just wanted to underscore two that I think will be important, especially for obesity papers and for physical activity papers. And these could be like the blue space metrics. That's something that could be innovative for some of those papers. I haven't seen that much in other literature. The slope is going to be important for behaviors like physical activity, and also underscoring that we are a different region depending on car use and transport. We also have the vehicle registration counts rates for not for all the countries, but at least from Brazil, Chile, Mexico, and Colombia. So those are other variables that if you haven't included those variables in your analysis for especially obesity, physical activity, and probably communicable diseases, it will be important to probably include them. So this is a little bit of an update of what we have for our built environment course. So I'm going to go straight on the questions for our panelists, who are Daniel, Alex, and Irina. And we're going to leave more room for more discussion with all the audience. So the first one is Daniel. And in this picture, actually, Daniel is not thinking about buying the 60 shots of aguardiente. from yesterday that we saw in our trivia. Actually, he was helping us to develop what you see on the right, which are our profiles, the profiles of the cities for the Salvador data. So the question for Daniel, which also was a little bit addressed yesterday, but today is going to be expanded, is the following. Oh, I'm sorry, here. What important longitudinal questions regarding the impact of the built environment on health in cities should we strive to address by adding longitudinal measures to the existing data? So I'm going to leave that question to Daniel. And after Daniel answers these questions, we're going to ask the audience if you want to expand a little bit more on that. And then we'll go to the next question with Alex. Go ahead, Daniel.
Thank you, Olga Lucia. Thanks very much. I think this builds very nicely from the previous discussion yesterday on longitudinal analysis. And maybe as a reminder, some of the time varying data on outcomes that we have include mortality, life expectancy variations in those, and then the causes of mortality, for example. And this builds on Marcio's comment, for example, on crashes, on accidentes siniestros over time. We also have the survey outcomes, when we might have some repeated cross sections available for some countries. So these are naturally some of the outcomes that we might be interested in, the mortality and some of the morbidities and behavioral outcomes that come from the survey. The third outcome or set of outcomes would be some of these intermediate outcomes that could be mediators for health outcomes, but in themselves, they could be outcomes. I'm thinking about pollution, and I'm thinking about atmospheric temperature, that is heat, and I'm thinking about land surface temperature. And I would leave to Irina that differentiation of atmospheric and land surface being a very good way of understanding heat island, which is critical for cities. And it interacts closely with green spaces and developed versus undeveloped land. But the point I'm trying to make is that we have a number of outcomes that are of relevance and that are time varying, and so that they can really support longitudinal analysis. And so I want to share my screen briefly. Let's see, I hope you are being able to see my screen now. And so I kind of divided our measures of the core, of the physical environment core, in three broad categories, for which we also have longitudinal data. Now, keep in mind that it is possible to also think of baseline levels as affecting the longitudinal outcomes. And so that's something that I'll get to in 1 second. But in terms of the domains that change, or for which we have measures of change, we have the natural environment, and specifically green spaces. So we know greenness and how it changes over time with many T's, many points in time. We have the size of green spaces and the composition. So are they clustered, clumped in a certain area close to a unit, L3, L2, or are they checkerboard, more like a chessboard, all distributed? We have blue spaces, for which we have, this is water, and Olga Lucia alluded to this, for which we will have size, or we have size, and we also have a characteristic of how permanent they are. And again, we have many T's for this, not as many as green space, but certainly more than 4 or 5 time periods. We have what I call kind of the human natural environment, the human natural system, and changes in that system. These are the two variables that I call intermediate, the pollution and the temperatures, land surface temperature variables. And then the last one has to do with the human environment and changes in those. And I highlight here that we have fewer time points for these. In some cases, we don't have yet that second time point. And so that, I think this is going to be the bottleneck for some of our analysis, but I think this is what we should really strive for if we think this longitudinal analysis will make sense. The first one is built on having population over time, and that gives us information about population growth. I believe that population growth was already used in a couple of analyses. In fact, in the life expectancy analysis, it was quite important. Higher growth is related to higher expectancy. Population density, that thinks about population over that area, is also a variable that we will have at least 2 time points. We have the question about the footprint of development, or the urban footprint. And our expectation is to have 2, hopefully 3 time points in the past. Development fragmentation, and as I'm going to see highlighted right now, vehicle registration. And the vehicle registration does have many more time points than 2 or 3. So these are kind of the building blocks, if I can characterize it that way, to think about the changes. And now, in this next slide, I want to kind of reflect a little bit on the various approaches to thinking about this. And this is certainly not exclusive. But one idea is to think about change on change. So this is relying on the variables that change as an exposure and change as an outcome. And so anything that won't change would drop out of the model. And we're looking more at how changes explain changes in the outcome, in the mortality, or in the pollution, or in the life expectancy. The second approach is more thinking about an exposure that varies over time and that explains the outcomes at a given time, or with maybe lags. The third one, and here's highlighted in red, is that we're adding some elements. For example, we're adding baseline information that could be important. The fourth one would be thinking about an interaction of the time varying exposure with time. So this is telling us that maybe the effect is changing over time. And the last one is the cumulative exposure. So this probably makes a lot of sense for outcomes like life expectancy, where we're thinking about the average change experience until that time period. I've put in this next slide asterisks in the ones that I personally think are going to be quite persuasive and maybe quite interesting for us. Change on change is very helpful. And very clean. And likewise, that third bullet, when you have a time varying exposure that you also adjust for the baseline, or take into account the baseline, where you're starting from, your starting point, is also quite important. And the last one, which is the cumulative exposure, I think is going to be very important for issues of considering pollution and as intermediate outcomes and life expectancy. So I want to kind of leave it there because I think the longitudinal analysis is more constrained by the data that we have, and that's fine. But even there, I think that there's a lot of amplitude to be able to explore some very interesting questions. And so we can engage in discussion about specifics as we go through. I want to just stop there. Thank you.
Thank you, Daniel. So I'm gonna leave it for the audience to have to ask questions to Daniel. We also started a discussion of where to focus on, the longitudinal or all the other L3. So please go ahead, Usama. You have your hand raised. Go ahead, and then Ana Ortigosa.
Yep. Thank you, Lucia and Daniel. So my question is on population growth, which always interests me. And I'm wondering if we were to, because it shouldn't be that hard to have population growth at the city level for decades, right? It's as long as we don't want it by age and sex, it's a thing. Now, I wonder what's, with urban growth, there is a moment in which the level 1 AD in the 80s was not a level 1 AD. It was something different. It was several cities. How do we deal with that? Like, I'm like, when the city wasn't the city that it is now, can we really look at this long-term longitudinal thing, or will we need something else, to do something else to get this kind of data?
Usama, if I can jump in, I think this is a great and a hard question that other studies that have used longitudinal data have struggled with significantly. except that our task is much harder because we are dealing with many different countries. And so criteria about aggregation, merging, or breaking are going to be different across basically institutions, across census bureaus, and so on. My general reaction is that it makes the most sense to use a consistent geographic unit that is imposed by us, whether it's a level 1 AD for the year 2010, or whether it's the level 1 AD for a different year, and impose that template, that unit, backwards, exactly. So that would allow us to, in fact, capture some of that phenomena, which is exactly what I think has been happening in many cities, right? The growth is not happening in the central city because the city's pretty built out. It's happening in the edges. And that means sometimes engulfing some communities that maybe were a little further away and now are fully integrated 10, 20, 30 years later into the city. So one challenge that I see there is having the population data for that 30,000 person town that was in the periphery, and that maybe for 1990 just wouldn't be counted or would be included in some of the data. If we use that L1AD definition, maybe if we have the full census for all geographies, we will be able to do it.
Yes, so that's it with census data. Since we don't need it yearly, we just need something like long term. I think that will be the best thing.
Yeah.
Census data.
Yeah.
Thank you, Daniel. Anna?
Thank you, Olga Lucia. Daniel, I have a question for you, trying to think about, so we are trying to incorporate infectious disease approach to our research, or trying to implement some research on infectious diseases. And I think in the context of infectious diseases, I'm not a specialist, but I have been working with, outcomes as infectious diseases. The important thing there is the incidence. So you are just measuring incidence, and for capturing variability, I think it's important to have measures longitudinally, but for exposures that can be, I don't know how to say, like can be broken up in small pieces, like having measures within years, more than average over years. So far, the main exposures we have in our data sets are exposures on yearly averages. But I think that one of the things is if we want to see changes in the short term, or how infectious are evolutioning over a year or over a certain amount of years, that breaking up the timing into more small periods of time, I think it could be necessary or crucial. I don't know how. I know we have some measures that could be possible, but how you conceive that could be accurate or useful to implement or to use in research.
Anna, that's a very good question, and thank you for asking it. I think it really depends on the question and the infectious disease that you're considering. So maybe bouncing back to those of you that are thinking about COVID, or those of you that are thinking about TB.
Sorry, Ryan, I also wanted to say it's not only infectious disease. I was thinking some morbidities like asthma crisis, for example. It's a measure that I think it's necessary also to incorporate if we are going to make a statement on air pollution, for example, because it will be very important to engage you engage other people in this fight against air pollution with other outcomes.
Yeah. So absolutely. I think that to the extent that the question drives us to a more refined timescale, we need to consider what measures will allow us to do that. On air pollution itself, I don't believe Nelson is with us because he had a conflict. Maybe he is. It's tricky, and Josiah has been able to look at maybe measures that are a little more time-fined, sort of resolved in time, but I think that's going to be a challenge. Other measures like heat and then surface temperature might give us a little more information about sort of these daily spikes or almost hourly spikes, and they could be associated with a bunch of other interesting outcomes, right? around chronic diseases, or even some infectious diseases like respiratory outcomes. So I think there's some potential. Unfortunately, we're really constrained by the data for other things. But going back to where I was starting on, for example, COVID or TB, or even dengue, which we're discovering now in Belo Horizonte, a very interesting analysis that is actually following up other work that has been done. It's that maybe the coupling of some of our variables really helps us understand things better. So we're seeing, for example, in early results, a relationship with the density and a lot of negative outcomes. And I really think that that has to do with the nature of development, with our lower income neighborhoods being very, very dense. And by contrast, that development in heights, the buildings that tend to be high income in most of our countries tend to be surrounded by more greenery. And so if we think about the density with the areas around them, it does not end up being that high. There's just more space around them. And so that's, we think, and we're seeing it in our preliminary analysis in Belo Horizonte, that coupling the greenness with the density is a contribution to help us kind of clarify some of these effects that are emerging as well. So that's another opportunity that we think is possible.
Thank you, Daniel. And I think adding to that, we will need to start thinking about different frameworks for a region. One is density. Density is a nice variable that we have. We have seen from other countries that density is good, but also with the work of Usama, I think there are thresholds. And there are some levels of density that we, by living in our regions, know that are not that healthy. So also thinking about with these variables that we know are really nice variables from our core, thinking about how we build these different frameworks for a region will be very useful. And I'm going to give the word to Ione for the last question for Daniel, and then I'll move to Alex's question. Go ahead, Ione.
Yeah, hello, Daniel. I was just curious if you could explain a bit more the variables of development or urban footprint and development fragmentation.
Thank you, Ione. I appreciate the question because it just never hurts to go back to some of these measures that are not sometimes not that easy to understand and to refresh our memory. So it's a great question. So the footprint was developed from the premise that administrative boundaries are arbitrary, and that's what we're seeing in our mortality data. Some are very big, some are smaller, they change over time. And so the idea of the footprint was kind of saying, okay, what is the actual extent of the city, like the ink blotch of the city. And so we use the Atlas of Urban Expansions approach with some modifications to develop that urban footprint. We have found, and we've kind of did some validation at the L1 level to develop that footprint. Again, it is not perfect given that we have 371 cities, but we feel fairly comfortable that it is pretty good for the 371 cities. So it is kind of the extent of development in the city. It doesn't mean that there aren't green or vacant lots in the middle. There are donut holes and pieces in the middle, undeveloped areas, parks, mountains, mounts, hills, etc. And those could be within that urban footprint. It's just that then that would not be developed area, and those would be kind of the green spaces or the undeveloped spaces that were there. It's an existent variable. And the fragmentation is, again, the other existing variable that is thinking about how, again, disconnected is development in that footprint, how disconnected from each other it might be.
Okay, but then when you are saying that the idea is to have fewer time points, for example, for the footprint, is that we will be able to see if this urban area has grown? And
yes, okay. Yes, Ione, the idea is to basically to backcast, is to go back and estimate the footprint for previous years, hopefully for 2 more years in the past, based on 2 sources of information: remote sensing imagery for those years, and with information from 2010 that also helps us understand what happened. If something is built in 2010, or something is unbuilt in 2010, it's unlikely to have been built before. Not perfectly predicting,
Okay.
but we use that information for building that footprint in the past.
Okay, maybe just my question comes because I'm thinking inside my head, like, are we going to be able to see, for example, changes in land use? For example, can we identify some areas were agricultural before and then they got urban or something like that? I just thought when I read development in the variables, I thought it was something related to that.
So here's land use is a tricky question. Again, I look at Irina, who likes to think about land use as a landscape ecologist. So she thinks agriculture, built, mining, bare land. I, as a planner, think about land use in terms of cities, mixed uses, retail, residential, offices. So what we really just know is whether that piece of space was developed or not. Unfortunately, I think it's going to be much harder to say whether it was agricultural before, or a forest, or just a field of grass, or not. So we'll know it's not developed versus yet developed. It's a binary.
Thank you, Daniel. So I'm gonna go for the next question for Alex. So here we have the question for Alex. So here another picture for our expert on transport injury doing his sustainable transportation trip in the Ciclovia program of Bogota back in 2017. And the question for you, Alex, is, do you see any opportunities to leverage the built environment data more effectively to do policy evaluation or take advantage of natural experiments? What would we need to do, and how can we focus? And I think you have a presentation, so.
All right, yeah, thank you, Alicia. Let me share my PowerPoint here. All right. So, so I've been asked to talk about what are the opportunities we have to do natural experiments using our built environment data in Salar-Val, thinking about, like what data do we have, what would we need to do to accomplish this, and how can we focus those efforts. So we have really great examples in Salar-Val already of studies that are using built environment data to look at changes in the natural experiment designs. So the ancillary studies are great examples of these. We have the Vision Zero study in Mexico City, as well as the EcoBC study there. One looking at the Vision Zero policies. There might be things that are changing the roadways to make them safer, as well as the installation of speed cameras there. The bike share program for the EcoBC study. We have the Rucas and Vila Viva studies looking at housing and neighborhood improvements. Those are great examples of natural experiments and data that we could use to look at a number of health outcomes related to those. And of course, the Transmicable cable car installation in Bogota. And then there's also the sobriety checkpoints policies in Leon, Mexico, that we're doing as part of a Bloomberg-funded project with some of the Salar-Val data. So these are all great examples, and hopefully this can give us ideas, of what else we can do. So what can we do with what we have in Salar-Val? And I thought, overall, we can look at changes in specific built environment characteristics or physical environment characteristics on health. So these might be things, looking at air quality, or transportation changes, safety changes, changes that affect physical activity, or other specific health behaviors or outcomes. And I divided them into, 3 levels. There's street level, sub-city or neighborhood level, and city level data. So street level data, we probably don't really have much of that at the moment. They might have some things in the future of that. But this would be things like if there's changes in sidewalk design or bike lanes, or speed bumps are being installed on a street. If there's neighborhood disorder, parking changes. So these are like street level changes that we could look at, a set of streets or specific streets in cities. There's some of that work that's in the Vision Zero study in Mexico City. But probably more likely what we have, data available would be things at the sub-city and neighborhood level or city level. So this might be things where we're looking at, once we have, more longitudinal data, as Daniel has talked about in the previous question, changes in the street network. We'll see if we're able to obtain something on that. But there's changes in greenness, population density, maybe in food access, or if there's things where cities have implemented street closures to, in their city, in the historic centers or other areas to improve pedestrian or bicyclist access and limit car traffic. That's another great example. If there's parks that have been built or increased access to parks, or things done to improve air quality. And then there's city level changes, which could be things with our overall road density. If there's a lot of more roads being constructed in the city. If there's changes in mass transit, like a BRT, the cable car is a great example. Subway systems, there's some cities that are working on installing those, but what's what happens with the pandemic in those. As Danny mentioned, there's changes in urban form and growth. This is a great opportunity, I think, at the city level to see how things change once we have those data and impact different health outcomes. And there's things, changes in air quality. We can look at not as itself as a measure, perhaps what can be an exposure, which also be an outcome, I guess. We could look at city typologies. We have, the city typology data to create those over time, to look at how those change. And there's, of course, temperature changes that might be another thing to consider. So one other area I think that we can think more about, for Sourdough also that I think is important is this, how are built environment changes or the built environment in general related to health equity and thinking about those in terms of natural experiments. So, the social environment group talked about a lot of great, social programs that are being implemented, and some of those do come with built environment changes. So if we're thinking about, if there's improved access to transportation or parks, healthcare, healthy food, or other essential services, those are things that we could think about looking at a natural experiment. If those are things that of in your cities or countries that we could examine. If there's changes in healthy and adequate housing, things that we could maybe, use the census data, over time, look at changes in sanitation, water, housing material, variables that we are, already collecting for the census data and look at those as, they are built environment data and look at how those impact health as well. And then there could be changes in employment and commute access that we could also think about. So how do we do this and what can we do to focus? I've just given some ideas here. So things we need to do, obviously we need, more longitudinal built environment indicators. Those are things I think, Daniel mentioned and that we'll be discussing more over time here and what is possible and what's not. We want to identify what policies can we evaluate with the data we have or we know that we'll be obtaining. We want to be able to choose the appropriate health outcomes for looking at we want to be sure if we're looking at a change in built environment feature that we're choosing a health outcome that we can expect to see a change in the time period available or the data that we have available. Thinking about if there's other data that we need to obtain or process or add to our Sourdough data would be a good question. And also taking advantage of that we have the fact that we have so many multiple cities across countries and sub-cities and what types of changes across those or comparison would you use, in different types of study designs, and what kind of study designs are best to look at these. There's examples of time series that we're doing for some of the ancillary studies. There's synthetic control study design that we're using for the Bloomberg project, and there's other designs we can think about. So in terms of focusing our efforts, I mean, some ideas that I thought of, for one, prioritizing which indicators are most important and would maybe perhaps see the most impact across a number of different policies in terms of, these natural experiments that could be used in numerous studies. Think about how we can use the ancillary data more and other existing data with our built environment data or other data that we could add to it. Thinking about how we can combine, data generation or analytical efforts, to make things more efficient. If it's like a study design, for example, with the Bloomberg project, we have the static control method that the steps we took to select the the control units and think about how we can use those same types of efforts, to apply to other questions perhaps. And then thinking, like, are there national policies that would be useful to look at to, see if there are differences by our subsidy or city built environment factors and health outcomes. That might be something else to think about. And then, enriching local efforts with Salary Ball data. If there's local, some sort of local built environment change or policy that's implemented in your city, like how can the Salary Ball data be used to enhance that? And once I go back to the Bloomberg study, because it's one city, we're looking at one L2, and we're able to use, Salary Ball data to identify the control units and create this comparison group for that study. So there are many ways of doing that to get advantage of our data as they are. So that's all I have, so I'll open up to questions.
Thank you, Alex. So now do you have any questions for Alex? And I also had a question that could be answered by Alex and Daniel as well. I don't know, Anna, if you want to ask that question.
Me? Yeah, I mean, it just occurred to me, Daniel, as you were speaking, that, maybe it's possible to create some simple typologies, simple of change, using just 2 or 3 indicators, the ones that are easiest, because I think that would be super novel. And because, as you said, increasing density, if it happens in the context of one thing, may be different than if it happens in the but it's just something that allows us to say something about cities that grow this way or that way. What are the implications for trends in air pollution or life expectancy, or I think that would be incredibly interesting if we could do it but keep it simple, and even just 2 time points over 10 years.
Yeah, and it sounds to me that maybe the way to think about it is thinking about rate of change as a strata. And so you have kind of fast growing versus slow growing, and within them, you might have 2, maybe 3 characteristics that describe that change. Inequities, Aleviva just said, absolutely, and how that rate of change is also related to inequalities. It's very interesting.
And we can build on the work, for all Colombia, that has been done, remember, using the footprint. So building on that, and we see, it's very useful also for policymakers to see how Bogota is changing versus Medellin, so things like that, but they haven't linked anything with health. So maybe just choosing 2 variables could be useful, density and, fragmentation, and it will be a better use of the level UX as well. Okay, so now any questions for Alex? For possible natural experiments? Okay, I have a question because I didn't think about like what you're doing with Leon, that is using your own Salary Ball data. And I think we can incorporate that for both the evaluation of bike share in Mexico and also for Bogota cable car evaluation. So but you didn't collect more data, just use the actual Salary Ball data from level 2?
Level 2, yeah. Yeah, so we used that to identify, essentially control units that were similar, other L2s in Mexico that were similar to Leon in terms of those characteristics. So we looked at the population density, the intersection density. We looked at the size of the urban area in the L2. So there was 6 or 7 factors that we chose to select those controls. So a part of the synthetic control thing is there's this weighted method to come up with like how much the outcome data is being contributed to the synthetic unit. So I think in other and even in other quasi-experimental designs, I think that would be possible to think about using those data to finding appropriate controls for when we're looking at these interventions that way.
It might be interesting to give a short, at some point, introduction to the synthetic control approach. Alex and Jordan is also an expert. Can do it in his sleep. So because it has its challenges, it's imperfect, but it's kind of interesting, and certainly the data we have lends itself to that for natural experiment evaluation very nicely.
Mm-hmm.
So it might be something to disseminate more with the group because there may be other ideas.
What approach, Anna?
It's called the synthetic control approach.
Wondering if we could do that in the context of also showing similar causal inference methods, like interrupted time series, difference in differences.
Yeah.
I don't know, is Priscilla around? Yes. Yes.
Yeah, and this goes back to something Carolina said yesterday about training in a natural experiment analysis for natural experiments, right? Which is basically, so, yeah.
Yeah, I think like our L2 data, our L1A data lends it to these natural experiments. So
that will be very nice.
Olga Lucia, I think you're muted maybe, or did we lose your audio?
What about now?
Yeah, I'm gonna
Okay, good. No, I was asking Rodrigo if he had a question. No, well, Rodrigo was thinking about how, if I read this correctly. Oh, go ahead, Rodrigo.
Sorry for that. I was thinking in sort of making, a comparative study on emergency measures taken by cities by the COVID. The COVID problem. More or less the same that we did in the seminar, in the webinar that we did a couple of months ago, and all this. All the measures that have been taken by cities as a result of the COVID, because a lot of cities implemented, bike lanes, emergency bike lanes, sort of increase the sidewalks as well, and all this kind of stuff to compare and to make an account of how cities are dealing with that. And since we're here, and there are a lot of cities that have been doing that stuff. This could be one, but I don't know. Maybe it's not interesting for.
Yeah, no, I think that's a nice idea. It's certainly something that there's a lot of transportation impacts from COVID, right? And so part of, I think, the challenge would be, collecting the policies and identifying them and gathering, them to some sort of grouping, if they're similar. And then also the timely data, a lot of companies have released, this mobility data. So we have to think about if it's possible to use that for these experiments. That's one thing, I guess, that's the challenge to these, is having up-to-date data. If it's like a recent policy change, you might have to wait to get the data that you want. So I think that's something to think about. But if it's something that's like maybe further back in time, it might be easier to implement the natural experiment. But yeah, the COVID one, certainly, you could think about that. And if there's the city level data that would be needed for that, then that would be a possibility.
That would be nice. And there's this group with TONA who are collecting best practices during this COVID pandemic. So I think we can add that, and our data from SolurVal could help us to provide some context. Which are these cities? More than cities, larger? Is there a pattern? We don't know yet. So something like that we could use as a simple correlation, I think. So now I'm gonna go ahead and give the word to Irina.
Thank you very much, Olga Lucia, and thanks everyone.
For your last question. So remember this, Irina, when we had this really nice trip before our SolurVal meeting in Antigua. So for Irina, the question that we have for our built environment core is, what are some important questions linking built environment to climate change or built environment to natural environments that we can address with the data we have or with data that we can add relatively easy? Go ahead, Irina.
Thank you. This is a very interesting question. And I also would really like to thank Daniel and Alex, because what they had mentioned also strongly relates to some of the points I was hoping to make. And it's exciting that a lot of the current papers in progress, as you may have seen from the conference and other interactions, are already addressing some of these questions, and the ancillary heat proposal that was funded, and there's several working groups there. So there are a lot of interesting opportunities. So I would like to talk about a couple of thoughts that are a little bit, might help us push this a little bit further, both the data that we already have and kind of help us start thinking about what are the gaps in our understanding of urban development and how it translates to climate change that might also need to be addressed to help us also kind of advance the frontiers of the public health questions related to that. A lot of urban studies, even though urban geography and a lot of urban studies have been around for decades, there are a lot of new questions that are being addressed at the moment, and there are still important gaps in our understanding of cities at the broad landscape scale and at the local scale, in part because of historical limitations in spatial data and maps that still pose barriers to public health questions. But we can start addressing these now, and I think there are some really interesting research opportunities there and collaboration opportunities. One of the points, so I have kind of three main highlights that I'd like to talk about. One of them relates to Daniel's point about temperatures. We have access to publicly available products of both the atmospheric temperatures in cities and land surface temperature. Land surface temperature, just to clarify, this is a kind of a product that comes from satellite data sets, and it literally is meant to represent a temperature of the surface of the Earth in a particular location at the time when the satellite happened to be passing by. And while we know exactly those times and locations, the challenge is that the land surface temperature is very snapshot. One of the most popular free products that we have comes from NASA MODIS products. They collect this data from approximately the year 2000. And there are only 4 times a day. There are 2 different satellites that both come daily and nightly. And so there are only 4 different times of the day that are captured by these products if you have no clouds and things like that. Nevertheless, these data are very interesting, and they're interesting in a way for cities because a lot of precursors of urban heat are very complicated and they interact with one another. Urban heat can rise because of the way we build cities. Built environment absorbs solar energy and then releases it as a heat and contributes to changes in microclimate differently than in agriculture or natural landscapes. There are emissions from traffic, from energy systems, from fossil fuel combustion. There are big aggregations of humans and human activity in cities. And all these factors affect microclimate, but they're very complicated, and we still don't have a lot of data globally for cities to help us disentangle it. So one of the interesting directions that I see in this is actually investigating the relationships between atmospheric and surface temperatures. Because even though they're strongly correlated, obviously, if you have hot surfaces in the city, you would expect the air to be hotter as well, but they're not the same. And there are some scattered studies that show that actually sometimes they correlate and sometimes they don't. Similarly with greenness and dynamics of green space, I apologize terribly. I have something happening behind my window. I'll move to a different room. There's also a very wide common assumption that green space elimination and reduction with urban development contributes to hotter cities. That is also correct on the one hand. On the other hand, it is not universally true because of all these other contributors to urban heat in cities. And investigating these couplings between green space, atmospheric, and land surface temperatures could really help us better understand these hidden drivers for which we may not have data, but we might obtain their indicators from these investigations and help us better relate these to the health questions at hand. A related issue is also that you may be familiar with the term urban heat island, which is basically a measure of how hotter the city is relative to its surroundings. And there are right now a lot of established techniques already in the atmospheric sciences and urban geography about how to measure heat islands, but that's another variable that could be also developed and looked at in addition to the sort of absolute magnitude of the temperature of it, or the temperature change per se. Is the magnitude of heat islands something that also might be related to human health outcomes, infectious disease risks, and other questions that might be related to microclimatic shifts? This links me to the second point that I wanted to highlight is the green space. We're developing green space metrics. We have access to long-term data on urban greenness and indicators of vegetation cover. And as we're learning from some of the current studies, this also creates interesting opportunities to think about the infectious diseases in cities. And one particular question that I feel like has been sort of addressed in some of the literature, but perhaps could be probed a little bit more with the richness of data we have, has to do with the fragmentation of green space and spatial pattern and configuration of green space. Green spaces, as you know, are a really hot topic right now, and they're very important as a public amenity, as a source of recreation, public health. From the environment and an ecological perspective, they're super important as wildlife habitat and as hotspots of biodiversity, connectivity for species whose habitat had been eliminated by development. And that creates a certain conflicts when it comes to diseases, because hosts and vectors of infectious disease may also use it as a habitat, thereby increasing potential human exposure. But as it is increasingly recognized, it's, there's also this interesting kind of controversy that indeed being closer to green space could make humans more vulnerable to this. But it's not necessarily just because of animals or other hosts and vectors using this space per se. It's because there's so little space left in the course of urban development that they're becoming more concentrated in those spaces, and then humans become also more exposed as urban development sprawls and encroaches on these spaces more. And that controversy in itself is really interesting because it relates to the question of how to reconcile the challenges around green space management, provision, and combining ecological goals with the mitigating risks to human well-being and the disease risks. And again, I think these questions are potentially interacting with climate as well, as climate might be an additional confounding variable affecting the disease risk and the associated animal populations. Lastly, I wanted to mention that we can also start thinking about some of the newer spatial products that are emerging and could also help us relatively easily, maybe sometimes not as easily, but push some of these questions further. I would particularly wanted to mention a new NASA remote sensing suite of products that is relatively recent. The satellite from which they're coming has been only launched in the summer of 2018, and it's called EcoStress. Some of you may have heard of it. It's not intended for urban studies per se, but I think it offers a tremendously interesting opportunity because this satellite basically is aimed at new kinds of thermal sensing and production of thermal products, particularly, again, land surface temperature, measures of evaporative heat stress, and measure of plant water use efficiency at spatial resolutions much higher than previously possible. So certain products are at 17 meters pixel size and minimum mapping unit, and some products are even being developed at 30 meter resolution. I think this is extremely significant because these products can really help us get at some of these heterogeneity in cities and microclimates at levels applicable to level 2 and possibly even level 3 units of analysis, not only level 1 ID. They also can answer questions about plants in cities. If something looks green, is it really cooling the ambient environment, or is it also drought affected? And when the plants are kind of heated up, they may look green for a while before they die, but they're not necessarily functioning in the way that would really stimulate cooling. How that varies by climate as another framework and another kind of stratum in the population of solar ball cities. And really kind of I think really the spatial resolution of these products is a huge advantage. And again, even though they're fairly recent, they could be compared with the trends that we can observe from the past data or from changes in population and cities, from changes in certain disease outcomes. And that could also lead to some new ancillary proposals that could be dedicated to development of these products and helping us to incorporate in the broader solar ball workflow. A lot of products today, just to kind of put this into context, so land surface temperature from MODIS satellites has been at 1 kilometer. So that's much coarser than 70 meters. And the atmospheric products, they are even coarser. So they're 9 kilometers, 5.3. So they come from models that have not been designed for the fine scale heterogeneity of urban environments. So I'd like us to kind of start thinking about these opportunities as well. They link vegetation and climate, and they also can help us link heterogeneity in built environment and climate better. And by the way, the temporal frequency of this newer EcoStress is going to be something between 1 to 7 days, depending on location on the planet. They're freely available. Of course, clouds can also interfere, but that's still important. By the way, they could also help us look closer into the seasonality of vegetation in cities and get at that higher temporal frequency relevant to some of the disease cycles and animal cycles that could be related to the dynamics of plants at a finer scale than a year. I'm going to stop here, but I'll be happy to talk about this more and answer questions.
Thank you, Irina, for enlightening with all these opportunities that we can have in Salurbal. So there are some questions. Ione has a question, but I think Andrea Cortines was first asking a question on the, is that okay? On the chat, and then you go ahead, Ione.
It's about the resolution of the new images that Irina was mentioning, and what would be the implications of getting data at a much smaller resolution, how that might impact the results that we might be obtaining. And also, are these tools too expensive, or are they affordable for a project like ours?
So this new thermal products that I had mentioned, they're all publicly available. All the data that I have mentioned, they're freely available. This particular new product, they are not yet sitting on the platforms where they're like super easy to download. It's possible to do it, but they will, normally a lot of these products right now become available through Google Earth Engine, a web programming interface where it's very easy. We've been using it to clip it by the city boundaries and organize into tables. They're not there yet, but they will be. And so they're free, they're completely free. There is a certain amount of effort that's needed to pre-process them, to kind of calibrate, clip, organize. That's always a bit of an issue, even though it's much easier with the web tools. The advantages of higher resolution are kind of multifold. One of them is that they can be representative. So the data can be representative of smaller areas locally, which can help provide a little bit more robust evidence about neighborhoods and localities. Because when you deal even with 1 kilometer MODIS data, which has been considered a standard to date, it's still larger than a single park. It's still larger than a single block. 70 meters is also quite coarse for cities, but at least you can start getting a little bit closer to variation that is because of this contrasting types of environment nested within the city and their spatial relationships. And I think that is sort of, that's been a big limiting factors in cities in general, because to date, we could only think about some sort of general trends with maybe some sense of heterogeneity. It also can help us translate some of the ideas a little bit better to policy design and management interventions, because when you can say that it's because of certain configuration of green space or because of certain composition of the urban environment, then we can go to planners and say, look, it looks like these types of planning approaches lead to higher heat risk or higher rise of the heat with ongoing development versus these kinds of planning. It's a little bit easier to then translate it into the local scales of decision-making and typologies of urban environments that could be changed through interventions for better health. And today, that kind of cross-scale communication has again been very limited by the fact that design and planning often works at very local extents, but these atmospheric patterns and assessments of microclimate have been done at really coarse resolutions or in cities as a whole.
Thank you, Irina. Ione, you have the last question. And I think Yang, you're going to be the last one with your comment. Go ahead, Ione.
Hi. Thank you, Irina, for all these highlights. I think they are very interesting, and I think I'm very aligned with your vision. I have some, I don't know how to say, like some doubts, or it's hard for me to understand properly how you align these questions with the Salurbal framework, just because, so I have the feeling that a lot of things that you have said more related to temperature and green space are related to the interaction between the urban environments and the surrounding environments, right? For example, you said about defining urban heat island. I'm not so sure how you're planning to define this, but generally it's the comparison of temperatures between the urban area and the surrounding areas, right? And then another question is related to green space. Also, I'm not so sure to understand well how you plan to link this fragmentation in green space with the movement of different species, because again, this is something that you need to take into account the surroundings of the cities, right? So for example, there's a paper from Nature that actually talks about that, like these changes in land uses, how makes this differentiation or these differences in biodiversity coming from outside the city, inside the city, and how this is linked to the increase of infectious diseases or vector-borne diseases. So, well, I don't know if I'm explaining myself, but when you were talking, it was kind of difficult for me to put all this framework only thinking about cities.
Yes, Iona, this is a really good point. And actually, this is something that I wanted to get at as well. I think while we're not looking at the whole landscape between the cities, there are very important connections that perhaps we don't have to tackle in their entirety, but certain research questions could think about these questions through the lens of the urban environment and through the lens of the city, right? Because if you're thinking about infectious diseases in your latest example, we certainly cannot know the full picture about all the animal movement or kind of their habitat impacted elsewhere outside the cities. But to the extent that then they come and interact with the urban green space or green space immediately around the city, the effects and consequences of that could be captured in the incidence of certain diseases or in the exposure of the urban population to that. And they could be kind of approached from that perspective on the one hand. On the other hand, I also wanted to show that there's a lot of new opportunities with the spatial data that can help us start thinking about new questions of public health, like urban heat island, for example. There aren't, in fact, many studies linking urban heat island as a global geographic phenomenon to public health per se, as a lot of studies tend to focus more directly on the temperature effects or effects of the temperature rise. But it's also, from the kind of human population standpoint, thinking about the migration of people who live outside the cities into cities, thinking about the differences among climate and the degree of genetic acclimation and potential, like in populations who have lived in a certain climate for a while versus people who are moving between cities or changing regions. There's a plethora of questions that could be answered. I do not do research in public health myself directly, but from the geographic science perspective and remote sensing perspective, I'm really excited about these opportunities, and I want to offer them for the public health experts to start thinking about, and perhaps thinking about cross disciplines in that as well.
Thank you, Irina. And I think, Yang, you had also a comment on this, and then we will close the session with just one last question that the Built Environment Core has for all of you.
Yes, so Andrea posed this question about the data resolutions. So it really depends on the data set. We have that information in the BE Core data dictionary. So just give you some examples. So like the L1 UX green space, we did it at 10-meter resolution. The urban footprint we used to define the UX and also calculate some metrics is at 1 kilometer. And for the daily temperature that we recently got, it's at 9 kilometer resolution. So I think the implication is that you don't want to use an area unit that is too small for the data product. For example, if you use L3, which is very small, and you get that daily temperature from ERA5, then probably many adjacent L3 is going to have the same temperature measures because they are in the same 9 kilometer pixel. And that won't give you much spatial variation, particularly if you look at a very small, like within one city or two cities. So that's going to be a problem. So I think that's the implication here. Yeah. Thank you.
Thank you, Yang. And just to finalize this session, one question that we had from the Built Environment Core, and it's related with what Ione was saying, that sometimes these variables, the things that we have in our built environment core, even if we have the documentation, are complex. So one question for all of you is, what can we do from the core to make more available the data, but what can we do in order to really make these more understandable? We had a couple of ideas like webinars, or do you think we should record something, or we can expand our dashboard? So it's just a question for the last 2 minutes to really ask you all if you think we can do something from our core to make this data more understandable. Any suggestions?
Olga?
Yeah, go ahead, Leticia.
My last experience in understanding, for example, the travel time, the average of travel time and how it was calculated, was asking a meeting with you in the back and then presenting the proposal idea. Maybe if you have some open sections for specific measures, can help the group. Well, it worked with me and my group, so I think it was good to interact with you. It's different when you are reading the documentation there and from having a conversation.
We'll take a note of that, and we're happy to always to meet with all the different researchers. So, and if you have other ideas, please send us to our core, that we are eager to listen to other ideas to make this more easier for everybody. So I think we can finish now our session on the built environment core, and I think the next one is with you, Anna or Claire. You let